My name is Rony Keren. I'm the VP R&D in Liquidity-Capital, which is a fintech startup which is now becoming a real company. Basically what we do is managing funds, and our algorithms know how to estimate the success of companies we are invested at, so we'll be able to collect the money back and then some. So it's quite nice because it's all about data, but it's not big enough to justify Aerospike. Hopefully it will be. Anyway, I've been asked to give you a short demonstration and talk about reactive programming, which is something that exists for a few years by now. We can say that it is no longer new APIs because the Java developers of you got reactive support built in Spring Framework starting from Spring 5. And basically, if you knew that or you didn't know that, Node.js is all about reactive. The architecture of the web implementation there is basically reactive. So if any of you wonder why PHP is going down and Node.js is the new king in town, well, reactive, this is the reason, and you will shortly understand why. The first slide you are going to see as part of we've got something like 4 slides, so I'm not going to, talk about theoretic stuff too much, but basically the challenge to understand reactive programming is the architecture, is the thread or concurrency model that is implemented beneath and holds this system, and it is pretty amazing when it comes to big data and data streaming. And this is why there's a natural, can you hear me? It's okay? And this is why it is quite natural to bind these reactive capabilities with databases like Aerospike. And I will do this linkage later on. But first, let's try to understand what it is. What do we have, and why does reactive might be very, very relevant? Oh, wait a second, my guys. Manage to enter? It's okay? So let's try to understand exactly why reactive is so relevant today and why it can really solve problems. And I really choose some unfamiliar vendor, never heard about him, this one. And I will show you that Netflix is doing something really bad when it comes to data streaming. And as a video streaming company, VOD, these mistakes or incapabilities for working in a reactive way cost a lot of money, okay? So I just want to show you something here about how Netflix works. For that, let's open the Firebug here, and let's try to pick what happens every time Netflix streams video down to your houses. Okay, so right now there's some kind of
what is it you guys want to talk about?
Okay, I can pause it right now. I don't mind it going. Okay, got you. Thank you very much. Let's go back home.
One of those casual introductory shots, please.
Let me just take this one, okay, or maybe this one. Okay, now if we take a look at these, as you can see, it will keep going as I get my videos. Then what I see here is actually bunches of data. What you see here, the response body is the actual part of the video I'm seeing. Okay, so you get fragments of those video pieces, but I want to show you the real problem here. When I go here, I see that all this data for each one of these remote calls, okay, a slice of the video you see was wrapped in tons of HTTP headers for the request and for the response. And you probably ask yourself, well, what did you expect? If one movie weighs more than 1 giga in the resolution they provide here, then how can you expect this one to be downloaded in a single response, right? So we split it. What other way we can manage this? But when you split it, you make, and this is really important, you make big data bigger. I hope you understand that. Because if I want to get the chunks of videos and I wrap each chunk, first I split it and then I wrap each chunk in an HTTP request headers, and then I bring back the chunk of video in an HTTP response, and I do that for every piece of video you get for the whole 1.5 hours you watch the movie, then I probably waste a lot of data on bandwidth for just the headers, okay? So I take a very long letter, and to make things better, I split it into small letters, put each one in an envelope, which is the HTTP, and use tons of envelope, okay? Now this is a data abuse. Now, the reason Netflix works like that is not because Netflix doesn't know what I'm going to show you. They do, but they can't use it simply because they use AWS gateways. AWS gateways are based on MVC, and MVC simply doesn't work in a reactive manner. So I will start, and keep this in mind, okay? Because I'm going to show you how I will stream data, okay, in one single response in an event, and it will be over HTTP. So keep it in mind. Let's get rid of this one and go back here. So what do we have right now? No one hears me? So
We can hear you.
it's okay? Okay?
Yeah, we can hear you, no problem.
Okay, thanks. So basically, when you look at the slide here, you can see the difference between the MVC and the reactor pattern, okay? While MVC uses a controller. The controller is a unit that acts as a proxy, and this is really important for you to understand, because this is why we work with very unsuccessful solutions to actually rape HTTP behavior. As you know, HTTP works in a request response manner, but let's look at the MVC concurrency model, okay, and understand how threads are playing inside. Wait a second. How threads are playing inside, and you understand exactly the block we have there, okay? So what happens when I request the data? Then each web server has its own thread pool. The thread pool will actually be used to consume threads from the pool and handle your request. So basically, you can say that every time you send a request to a web server, there will be a thread that will be binded with your request context. And now it carries your request data to the controller to ask for what you want to do. Now the controller uses the same thread, or if you will fork anything here, then the thread here might be blocked, because controller works as a proxy. He asks something and he waits until he gets that something to return it to the client. So this is only because the controller are meant to work over HTTP, and this is how HTTP works. This is how your browser behaves. We send, we block, we get the data. So basically, here we can say that the thread will be back to the pool to be consumed by others only by the time the controller completes the whole sequence. If there's database involved, then you will block on the database reads and data loads and data parse and data convert and calculations and everything. Here we really need cache just to make this iteration shorter, okay? If we have the database in our domain, okay? So basically, I can say that we've got limits. For concurrent clients, the limit will be the number of threads in the pool. Now, pay attention to the fact that no one asks the client what he really wants to do. For example, let's say that one client takes a thread to stream a movie. So the thread is now gone for a long time. But other clients just want to see the movie catalog. So it's just a request response, which is pretty short. But let's say that we've got 4 people that watched movie, and we've got only 4 threads in the pool. So now we've got 4 threads at work. And the fifth guy came in and he just wants to see the catalog, which is a 1-second calculation. you know what we will get? A timeout. And why? Because there's no thread to take him. When those threads are at work, there's no one to answer your calls, no matter how short they are. So there's something really not sophisticated here, because we make the controller be a prison of your business logic, and it shouldn't be, okay? But this is how it proxies. Proxy gets everything and returns everything, so it has to wait. Now, what can we do to make this better? Because this is how MVC works. So we can still try to what I call rape HTTP, and we do that by two manners. First is to do refreshes. Refreshes like you saw in Netflix. Netflix will never dare give a client that watches a movie a thread for an hour and a half. It's not going to happen, because then the amount of threads in the pool is the amount of clients that Netflix can serve. So it can't be done. So they refresh, they split into tiny requests. So you can imagine that each and one of you see only tiny movie at a time, okay? So we can all watch movies, because no one takes the thread for an hour and a half. But we pay dearly for this, because as I said, when you refresh, you actually abuse HTTP. You send a lot of request and response headers on top of the data you actually use. So it doesn't make sense to work like that in a big data era. Make big data. I was muted by the host. Why is that? It's okay, it's okay. Just joking. Maybe it's very boring, so it's okay. I'm just kidding. Other way to do that is simply not use HTTP, is use WebSockets instead, because we say, okay, HTTP is over TCP/IP. That's great. So why should we use the HTTP? We can use the TCP/IP, and then we can send packets of data and push packets of data and do everything we'd like. Well, yes, but no, because when you use WebSockets, you are no longer working on HTTP protocol. You're beneath it. So as long as you work with browsers that actually support this, it's okay. But WebSockets suffers for inconsistency when it comes to client support. And think of that, the future of big data is IoT. So don't count on IoT to support WebSockets, really, okay? These are not power clients. It should be in many cases secured. So probably they will limit, restrict you to use HTTP. And WebSockets might be irrelevant for lots of IoT's implementations. So this is also not a solution. The solution is to do that right over HTTP. This is the solution. We'll see it soon, but let's take this reactor design and understand what is done in the web when it comes to reactive, because reactive is not just for web, but this is when compared to MVC, it's quite easy to understand how reactor changed reality. In this case, there's no proxy, there's a router. Means that the router accepts the request, distributes the request forward, and never tracks the request anymore. It simply turns back to any other client, says, okay, I'm available for more requests. In other words, what's different between the reactor and the controller is that the controller is blocked on the request, while the reactor simply throws the request away to a non-blocking channel. From there, it can be consumed by the model and be treated separately from the doing of the reactor. The reactor is always looking at the incoming requests, okay? It's simply, you can see my video. Well, if I'm the reactor, then I get the request in the front, and what I do is simply throw it away behind my back to the model to be taken care of, and I'm still waiting for more clients. So I never block. I'm always available. And if that's so, you can see that the only thread we need to use in the reactor is the thread that runs the reactor. It's a single-threaded application, okay? Now, I'm not going to lie to you and say, okay, now you can do big data with single thread. Of course not. All the threads will be here, as it should be. If I want to watch a movie and stream a movie, I'll probably use a bunch of threads for that. But if I want to use the model for seeing catalog, then I can use a single thread for this. So I can split the workers from the actual reactor that accepts the request. This one will be always available, it never blocks. So what is this? Well, we do need some offsets and auditing of the client. So pay attention to how it works. In the reactive world, when HTTP request is coming to the reactor, it takes the socket, the connection, binds it with some object here that's known as handler. This handler is no thread, it's just an object. So if I got all of them out of the pool, I simply create new one, okay? This is not heavy resource like a thread. Now, the thread takes your request context or request handler that holds the actual connection to your browser and throw it over its shoulders on a multiplexing non-blocking IO. The Java developers among you just know that it uses an IO in Java called the selectable channel. This is the implementation in Java for multiplexing. And from then, it gets, the handler gets to the model. Now, here I will deep dive and show you what is reactive here later. But what I'm trying to say here is that this context holds the connection to the client. So the reactor is not part of the communication anymore. Everything that is being calculated in the model will be thrown to you as an event. So suddenly, instead of waiting and blocking for responses, the response is actually a stream of events. Now, let's deep dive into this one, because this one is really important, because you will say to yourself, okay, what's the big deal? We change this one and we shift all the bottlenecks to the model. What did we actually do? Well, no, this is not the case. But for that, I need to explain you a bit more. So, how do we treat request? How do we handle request? So I can assume that the request is handled in a bunch of sequence. Let's call it a pipeline, okay? So this one is a pipeline of execution. Now, when I get a bunch of elements, and this is the request that comes from the client, so this thread has to handle the request and do a lot of things during this pipeline and eventually come up with a ready-to-use response. Now, this calls streams, right? We pipeline executions over some context to get out of this pipeline with some calculation that can be handed to the client. But the point here is that as long as we use streams, the thread is actually waiting for this pipeline to end. And this is blocking operation. So the thread is waiting for your calculation. And by the time you get the response, then it will be back with it. So it's quite like we said in MVC, okay? This is the point where the controller gets this response, and now it can be sent back to the client, and this thread is free to use to handle and serve other clients. We want to get it better. So in Java, it's called parallel stream, but it exists in any other places. Parallel stream means that when your client comes with a request to handle, what we do is simply split the pipeline according to the amount of available thread we address to this work. And now this splitting allows thread to maintain and handle your request in a parallel manner. But once again, guys, pay attention to the fact that this thread is still blocked. You can assume that now it will be blocked to less time because we've got more workers that split the work, okay? By the way, not always helpful, because if this one does a little sorting, then you can forget about the splitting, okay? For doing sorting, we have to gather all the parts and then we have to go parallel again. And this is exactly what happens. And what about events that are running during some time series? If you get an event once an hour or once a second, splitting the pipeline won't help you at all, okay? So this is really useful when you get a really big job to do and you want to, treat it and handle it faster than in single thread. But you got all the data, you know how to split it, and then you can address it to different threads. But once again, this is not solving any problem because once again, this client thread waits. So it waits less, but still it is blocked, okay? So what's the solution for this? How can we do it differently? Here come reactive streams. As you can see, there's the thread client, but the client thread, places the handler here and go away. So you can think that this is the reactor. He just threw the job and went away. Now he's not waiting to anything. The response is not passing by to the client through this thread. We don't need it anymore. Oh, sorry. So what happens now? Well, this is a genius thing. And I can compare it to the way time slicing works in the operating system. If you remember, you probably not. I don't remember this. But anyway, what we used to have at the beginning of time is operating systems that actually works in a priority-based way. Means that the highest priority process will gain 100% of the CPU I have to give. And only by the time this high priority process dies, I can shift the CPU to the next one. So there's a starvation. I don't have to speak about it because we're all living time slicing just for that, right? The solution for that was simply give slices of CPU time to each and one of the processes. We give those slices very, very fast, so we get a feeling that everything runs on the same time, okay? Take this idea to your code, and let's look at it now. What if I asked to watch a movie? So I dumped my request, and now this one goes back to ask for, to be ready to more movie requests. But right now, this is me, this is the connection to my browser, and I want to watch the movie. So pay attention to how it works. If this is the first frame, then the thread will be out of the pool. It will get my handler. It will ask the handler, which scenario you're looking at? What is your offset? And I will say, okay, my offset now is 0. I just started. So we say, oh, your offset is 0. Then you need to get this one. So we will calculate this one and we'll send the event. Okay? So the event now is reaching me. Okay? Now, the thread is not stick to the request. The thread is now back to the pool, and maybe the next offset will be played by different thread. And the third one might be played by the thread that's been used before. There's one thing that is not occurring here. There is no binding between client context and a thread. The threads share the context among them. They are doing execution slicing. So instead of me taking a thread for 1.5 hours, I will simply cause the thread to jump from the pool and, move the offset forward until I see the whole movie. But eventually, when I got the whole movie, it was several threads that actually streamed it out. Now, if you think about it, what is so neat about it is that what happens if another customer wants to see a movie? Well, no problems. Same thread will do the same thing on him too, okay? Basically, there's a scenario in which this thread gets out, pushes my offset from 5 to 6, and then back to the pool, and then he gets another schedule to push other clients' offset from 10 to 11. So we do execution slicing. Now, if you think of that, the amount of slicing you can do with the limited number of threads is much higher than the one you can serve, than the number of clients you can serve if you will bind each thread to the client, okay? So when we do slicing, we can actually talk like processes. There's lots of clients, but they all get served. Why? Because the thread jumps for each one and takes the offsets forward for each client. No one gets blocked, okay? The ceiling is much higher now with the same resources. So this is a reactive stream. And now if I get back here, you can assume that this is a reactive stream, okay? So we really get events from the business instead of blocking until the business is calculated. Now, it's quite clear that it's not for everything. If I really want to do some focused, easy to use, not continuous requests, then MVC is perfect. But if I want continuous requests, if I want to stream gigabytes over HTTP, MVC is not a solution. The reactor is the solution. Now, if I bind this one, okay, with a database, so there comes the magic. Because, and I must say that the real magic is that, in this case, Aerospike is capable of providing amazingly fast reads. So in some scenarios of flash setups, it can reach RAM performance. So this is no joke. And it means that I can stream events from the disk using Aerospike reactive driver, something I'm going to show you, to my stream. For example, my stream can say, I want you to take care for the resolution, take care for the delays between each event and the other, because if you've got a stronger screen card, then I can stream you large buffers. But if you've got a tiny device or a weak screen card, then I probably would like to reduce the buffers, delay the events. I can play with this. Okay, so there's some logic in the pipeline, but eventually I stream those events right from the disks to your connection, and you get it over HTTP. Now the magic here, and now I will refer to a code just to show it to you, okay? The amazing thing here, and most doesn't know that, and this is pretty amazing, okay? Because it's not new. HTTP supports this. HTTP supports streaming events. So we get the whole thing here. We get a very, very fast events from the disk, and this is totally Aerospike IP. And when we use Aerospike reactive driver, and there are like these, I'm as a Java developer uses one. So they actually take this rapid database and turn it into an event generator, reactive event generator. And then we take those events and we can actually stream them over the same HTTP request. So I think that this is a good time to show you how it works and how easy it is to be used. Wait a second, so I have to jump up my Eclipse here. So I use the Spring, maybe I enlarge it a bit, okay? I use a Spring Boot. So there's almost no code to write. I just want to explain what you are about to see, okay? The first thing I did is created some kind of object here. This object, this class here, works with, as you can see, Flux. Flux is a reactive stream. And what does it stream? Well, I'm not going to stream video. I'm going to stream you a book. I'm going to stream you Hobbit, the Hobbit written by Tolkien. So I got this book inserted into Aerospike already. So it's already in the database. You can see that I've used the Docker desktop and the Docker image to run this. So I've got, let me just show it to you for a second, just to see that it's all up and running. I'll open my Docker desktop. So you'll be able to see that. Wait a second, let me drag it to here. You can see it here, okay? So we've got the Aerospike running here, okay? You can see it, Aerospike server. So this is my instance. And basically, what I did is simply put all the lines in the book inside the database, Aerospike. So basically, I've got all the book, and the book is something like 6,700 something lines, okay? So what you see here is that me building a line, a stream of lines, stream of rows of the book, okay? Now, I'll show you another two twists of connectable Flux and auto-connect Flux. These are just fun. I'll show it to you later after I finish with the actual idea here. But what you can see here is that I'm reading the text file. This is done only only for the first time, only if it's not exist, okay? I put true because I run it with Docker, and all the time I write the Docker. When I take the Docker down, then Aerospike goes down and the data is removed. So I put true here, but feel free to do it like that, okay? And by the way, the guys from Aerospike, you've got the code, so you can share it. Now, what I do here is simply, after I put all the data in the database, I do this. I prepare these 3 streams. Let's focus on this one, okay? What I do here is going to the database. I do select all. I want all the rows. I sort them according to the index. Each line object has the index, which is the line number, and the content of it, the text. So I sort it, okay? So we get the reading from the beginning to the end, okay? And I print DB loaded. So as you can see here, I ran it already. And as you can see, the DB is created, and I've got all the book inside. And more than that, I've got all the data streamed. Now, you probably think that this one loaded all the data to the memory. Well, no, this is not a collection. It is a stream. It is a pipeline. It is lazily executed. Nothing really happens until you begin to consume the data. So right now is an active active reactive channel that is capable to stream data from Aerospike to the world. Now, just to show you the tons of data, tons of code I have to write here, and I'm really joking here. This is the ton of code I've written, okay? I don't know if you know Spring. Those of you who doesn't know Spring, I want you to see this one. As you can see, this interface is filled up with methods. All the methods, like delete, we've got a fully implemented DAO here that is already narrowed to my line object. You can see a line key, and line, all is according to the line and the primary key I've created. Here's the line. You can see that the line using, by the way, I'm using here, what was the name? Lombok. So I created index and content. So all the gets and set and constructors are generated automatically. But this is what this object holds, okay? And I created the primary key for it, okay? So this is something that Aerospike requires, but it's really simple to use. And when I do this and this, line and line key, all I have to do is simply create this interface, says that this interface will create a repository according to line and line key, and I get all this without coding them. Save all, whatever you'd like, okay? It is all already generated, but this is the magic Spring does. Now let's go back to our issue. What I'm going to show to you now is the web service, because we want to see that just like Netflix, stream to the browser. So here goes, we've got a REST controller here. We inject this reactive stream to it, and we expose it over HTTP with EA Orbit. And now you can see that I've got several endpoints here. Let's start with these two. I can ask to read line with a given number. You can see that I go to the Orbit, takes the reactive stream, and asks from this pipeline a specific element, okay? So this is pretty boring, because it will be like a request response. Let's see that. Now I have to find it. Here it is. Okay, so what I'm doing here, you see that? Hobbit, read, line, let's put here 1000. So I got line 1000, okay? But this is really no big deal, because it looks like a request response. There's no events here. But I want you to see, this endpoint. This one here, pay attention. Here we've got read from to with delay millis. So what I do here is actually put on the pipeline filter that will take only from until it gets to and will delay the elements according to the amount of milliseconds you gave me. Now I can tell him, okay, I want you to start with 0 and end up with 6,700, right? So we're kind of Netflix-like. We're streaming a lot of data. Yeah, and I would like to wait a half a second between each event. So now I'm going to sit and read for 1 hour the book in my browser. So it's like a movie. Okay, but I want to show you how this movie is going to be played when we use reactive. And pay attention that I'm using text event stream value. This is the MIME type. I'm not using application JSON, God forbid. So let's do that. And now I want to show you how it is. So let me jump this, once again, this firebug, so you can see the HTTP activity behind the scene. And now I'm going to do this. I want you to read lines 20 till 30, and I want you to wait something like, these are milliseconds, right? So let's put something like half a second, okay? Now, pay attention to what's going on here. Ready? Go. Well, do you see the headers? Do you see anything? Oh, you don't. Well, the reason you don't see anything is that because it happened in a single request. Let me do it again. Why don't I see the request? It's all here. It is. Wait a second. Let me do it again. Let me try to, not source, but network. Okay, once again. And now I want to stream it for, let's say, I want to stream it faster. Okay. Let's put here 10 milliseconds. These are all happening in the same event. What you see here are events on the same HTTP. But why can't I can't see the network as I want? Let me just close it and open it again. Okay, let's try to do it again. F12 like that, and let's try to do it. I don't see the. I want to see the actual request here. Why don't I see it? I don't know. No, I don't see anything here. It's supposed to be on network, but I don't see it.
You have selected filter by XHR.
Is there what filter? What do I have to remove? This one?
Upper.
Upper, yeah.
Lower. Yes, select all. Left.
Where do you see that? This one?
Bottom.
Oh yeah, the button, but where is the select all? I don't see it.
Now selected XHR.
Oh, where do I see that? I don't see it. Okay, Yevgeny is coming to help me. Yeah, how can I clean those? Oh, sorry. Yeah, this is the only one. Yeah, all, and now I see. Oh, thank you very much. I look at it, I don't see it. Sorry. Thank you very much. Let's do a refresh once again. I want you to see the experience here. Once again, you see that once I get pending. Oh no, this one is too fast. Let me just slow it down a bit. Let's give it 1 second. And thank you for the help, the assistance, by the way. Once again, we stream 10 rows. Okay. So pay attention to what happens here. We get pending, and that's it. You can see that it's done already. Okay. No further events, but I still get the data. So we don't abuse HTTP. Okay. And this is really important because we can actually stream the events, pure events. Now, let me show you some nice tricks that I can do, which are down to the API and can be forced over reactive streams. One thing I did, and let me take you back to the code to show it to you, okay? And the server is running, is up and running. Now, what I did, when I think of it, I really hope that Tolkien didn't finish up to tell the story, but you can see here, I put auto connect. It's taking the same stream, I put delay elements. So I asked the stream to be to start and throw events. You can see that publish and subscribe. So this one, I say auto connect subscribe. Okay, auto connect subscribe on this one. on this one means that Tolkien is now subscribing by itself. So what I'm trying to say to you is that one of the streams here, one of the reactive stream I loaded, which called Tolkien, is hot stream. Hot stream means that by the time I started the server, I started the subscription. So basically, Tolkien now is actually reading the book in a delay of 2 seconds to himself. The book is now read. It's like a live broadcast. So if it is live broadcast, let me take you back to the web controller here, okay? And you can see that I've got this Tolkien, okay? If I call read live, now by the time I was talking with you, the server ran, Tolkien was reading the book. So basically we can join him. Let me take this endpoint, go back. Opa, let's go back to here, and I'll paste this one here, and we're supposed to join Tolkien. Oh yeah, Tolkien is now on line 1727, okay? So this is like joining a live stream, okay? By the way, this is something Netflix haven't got. They are VOD. They doesn't stream live, but we do, okay? So you get the same experience with a hot stream that is already working. Think of an IoT that actually measures something and broadcasts. And you can connect to this broadcasting whatever you like. And by the way, you can stop it whatever you like if you don't want to get anymore, okay? And if I refresh, well, Tolkien is already around here. So if I refresh, I'll get it from the point Tolkien here. Now, by the way, I asked Tolkien to lay down in cache the last 3 rows he read, okay? If you are wondering where is it, so it should be here. Let me just show it to you. Replay 3. See that? Tolkien, replay 3. I said to him, whenever you get connected, you always keep the 3 last lines you've read, you've streamed in your cache. So if there's any new connection made to the hot stream, you'll get the 3 last lines he read. Okay, I can turn it to 0, but this is what I want to show. Another nice thing that you can see here is that I've created another channel, and this channel does another thing. We publish, but only after we have 2 subscribers. Oh, that's nice. I can put 20 subscribers. So only by the time we've got 20 requests for the stream will start. Okay, let's see that. So for this, let me just see how do I return this auto connect. Let's go back to the controller. Now you can see here, auto connect. All I have to do is auto. But when I read auto, it means that I'm the first one to read. So let me just open. Another instance here. Okay. Let me put this one, localhost 8080 AE Hobbit, which is the prefix, and I put this one and I do enter. Now see that I requested that, but I get nothing because I put 2. I need another consumer to get it going. Okay, so let me just open incognito, and we'll do it from there. This will be the next client. I will open it and show it here in addition to what is already open. And now I'll ask again the same thing and see what happens. This is the second request, right? So we get it. Both get it. Okay, it will be streamed only from the second request because this is what I said for the replay. So basically, we can play with streams as long as you want. And once again, I remind you that this is all happens on the single HTTP request and response. There is no headers abuse. Okay. Now, basically, this is what I wanted to show you, and I believe that if Netflix could work like this, it will save a whole lot of money for her, for the company, for bandwidth, because you can just imagine how many HTTP redundant HTTP headers they send over HTTP for you streaming videos. Okay, there's plenty of clients, plenty of instances, plenty of requests, and tons of data. So they really abuse the bandwidth. Okay, and eventually at the end of the year, when you run on Amazon, it costs you. It costs you. So this is it. Now, if you and this is when I want to do the linkage. After we saw that, okay, I want to do the linkage with the Aerospike here because it's really important. Because basically we can do that with any NoSQL database. So what's the point here? Well, the one thing that is really unique when combining reactive capabilities with Aerospike as a NoSQL database is the fact that Aerospike provides you disk-sourced events with the performance that is close to RAM. So if you think of it, Aerospike is the database and the cache. As long as I've got the database and the data in my domain, I don't pull it from any third party, so I don't have to cache it. I got it. You don't need cache. Okay? And this is amazing because you think if you think about it, the amount of efforts we spend on these, that's amazing. And these become even more crucial when we stream data in big data era because it's a lot of data and high concurrencies. And when IoT enters, it will be even worse. So that's amazing because as long as you've got your domain and the data is there, as long as you've got flash media, you pay for it. But if you use Aerospike, you really want fast reading. So if you take this amazing fast reading and pull reactive stream over it, and then reactor for HTTP, reactive experience, you get amazingly fast events from the disk to your browser with no need in cache. Cache will cause you to work slower. That's amazing. So this is a great. When I first heard about Aerospike, it really, it was like it meant to be. Suddenly, I thought that all the demonstration I'm doing with the other databases are really not in place because I do pay the price of disk reading. And no matter how big the data can be in NoSQL, I do need some cache capabilities. And suddenly, I get amazingly fast events, and cache can be something alternative or something that is reduced for really specific things. We don't need to invest in that. We don't need to maintain that. We don't need to pay for products that does it. There's a world of products for caching. Suddenly, everything is solved. So basically, this is the main thing I wanted to show to you, and this is the strong bindage between Aerospike performance and capabilities and the reactive way of streaming data. Basically, this is it. If you've got any questions or clarifications or anything, I'll be more than happy to answer you.
Rony,
Yeah.
actually, I do have a question. Actually, two. Okay, so one of the first question, in your example, you showed that the two clients can read from the same stream, right?
Yeah.
What if I would need to adjust my stream to a specific client? Let's say we are watching a video and my connection goes really slow and I would need to adjust the quality of the video to that specific client. Would it be possible with your model?
When you talk about the resolution, for example, so let's assume that I've got the amazing resolution on my disk and that I reduce it according to my client, okay? Because streams cannot add resolution if there's no. But I can take the same data set from the disk and stream it to all kinds of clients in different pipelines. What you actually asked me, you can see here. Here I take the same, let me just remind you, it works lazily. Nothing is really loaded to memory. So it's not like you work with a collection and now we want to do several iterations on that collection, okay? Well, basically, this is how it is, but the collection is not in memory. It's my database. So you can actually add more implementation like that. Hobbit get BOD, which gives you the, let's say, this is the connection to the actual data, the event-driven data. And from this point and on, you can do whatever you'd like, okay? So when a client enters through this iteration, it will get this pipeline on the same data set, okay? Because once again, the data set is never loaded. But once again, I must say that this is same goes here with streams and parallel streams. As long as you're, and this is what's so amazing with streams in general. Streams are executed lazily, okay? So nothing is loaded to memory, unlike iteration you are all familiar with, okay? This is, by the way, called internal iteration. Streams are implementing internal iteration. When you work with iterator in Java, for example, this is called, or the iterator design pattern, this is an external iteration, okay? So it's eagerly executed. It cannot change anything, all this stuff. But here I can create sequence of executions. You see that it can be 1 kilometer wide, nothing run until you actually step into it. So I can create lots of them, lots of iterations which are potentially can be invoked, okay? And that's it, these are your endpoints. They even won't collide because each gets the event from the BOD on each handler with its own offset, and each client's offset gets treated by its own pipe.
Okay.
So they won't collide.
So basically, the somebody is reading the events from the socket and feeding it to the model, like to the controller. And somebody is it React who is listening on the sockets and feeding the events to your controller?
You can think of it as if two different clients came with different sockets to Aerospike, okay, through this pipeline. So Aerospike starts to, these are two selects because these are two iterations. So basically they will start to get events like that, okay? Now it means that Aerospike is also, the driver is also reactive. So if it takes you, this select takes you 1 week, it won't be single thread that gives it to you. These are also threads that share the event. So basically Aerospike with reactive driver can serve a whole lot of clients, okay? Each comes with its own handler and its own offset, and the events goes accordingly, just like stream, okay? So there's really nothing that can work faster than that.
Okay, so basically you were saying that the event is could be compared to a select that runs on the Aerospike.
This is the exact thing. Yeah, exactly. When you do select, the experience will be getting events, which are not dedicated to a specific thread. There's a whole family thread that answers you and others and share those select events. Okay.
Okay. And who is reading the events from the socket? Is it a React controller that actually listening on the sockets and then take the event and feed it to the system?
Yeah. Okay. So basically, this is the exact IP of Aerospike here. Aerospike provided the reactive driver. Okay.
Okay.
So this is what's doing the magic from the disk. I know how to take this magic into my business logic as a developer and insert the event into my pipeline. And from there, I give it to the reactor back to the client. So we get all sequence event driven.
Okay. Yeah, great.
You can see here, by the way, if I'll share it with you, you can see here. By the way, I said it already, okay? The project is shared. You can take it and enjoy it, and you can send me request if you need help to run this. What you'll need is Docker running because it also launches Docker, but you can see here, you can see two dependencies here. First is the web flux that gives me the reactive and reactor web experience. And second is simply reactive Aerospike driver. Okay. And this one is provided by Aerospike. So this is what's so amazing about it. You enhance your performance and actually doing nothing. All I really did here is coding the Hobbit Flux, which most of the code here is putting the book inside the database, which is this. What you saw, which is relevant, is only this part. This is it. This is what I really needed. And the other part was this one, which is really, you know, we all do that. This is REST. This is a controller, but it's not a controller, it's a reactor, okay? Simply because it works on a reactive and these kinds of media types. And it works, of course, with Flux, okay? Flux is a stream of several events. Mono is a single event, okay? So it's the same thing. But basically, there's nothing here, really. This is what's so amazing.
Okay, great. Thank you.
Welcome. Other questions, guys? Okay, so I managed to put you all asleep. I'm really glad about it.
Thank you, Rony. There's actually a hidden assumption here, and this is what I'm going to talk about in a second.
Yeah.
Behind the scenes, there's random access to different fragments of the data. So in order to actually do what Rony just described, we actually need some way to fetch data from somewhere. Rony used Aerospike, and I'll explain why he used Aerospike in a second. But we need it in a fashionable way without even knowing what will be the next fragment of data or record that you will be reading next. And that's the big thing here, because if you don't know what could be the next item that you're going to read, and you want to stream a movie, and you don't know which of the parts will be sent to the client next, you can't cache it. You can't put it in memory. You can't pre-read it, preheat it, and use it ahead. And what Aerospike provides, and we'll talk about it in 2 seconds, is the ability to do that from the device itself, from disks, and not from memory. Don't store anything in memory and still get the capabilities or performance that you would get from a cache database. And we're going to see a live demo for that in a second.
Zohar, I want to add to what you said right now. If you look at this one, okay, this is quite amazing, because if you can see that, I put a sort here, but still it is lazily loaded. So somehow magically, Aerospike is maintaining some indexes here and know how to sort the events, okay? This is a real magic, because no one is getting loaded here, okay? So yeah, I believe that these are the Aerospike experts will contribute more information about it. But as a developer or services developer, and in big data era, you should consider working like this for streaming data, for simple push, which is amazing experience over HTTP, no WebSockets, no refresh abuses, pure HTTP, and you get push. So this is quite amazing. Okay, so I think that my job here is done. And from here now, we are going to discuss the specifics, Aerospike specifics. So I'll put myself on mute. And thank you all for this. And by the way, you are all in touch with Zohar or the team from Aerospike. So if you want the sources in the presentation, just say.